Hi class, welcome back. So we're still in week 2 and now we're in lesson 2.2. I hope you had a great time practicing learning to observe nature with a sort of different lens and with the lens of a designer. And now in lesson 2.2 we're going to really focus on functions, so observing functions in nature. And I just want to spend a few minutes before you dive in talking about what we mean by function. So in lesson 2.1, you were learning to observe nature as a designer. So I hope part of your experience was, in addition to seeing something, for example, a flower, and asking what kind of flower is that, which is what we typically do, right? You also dug a little deeper. You started noticing things differently. You might have asked, why is it yellow? Why does it smell like that, whether it's a good smell or bad smell? Why are there so many petals in this particular flower? Why is that middle part arranged as opposing spirals? And why is it fuzzy here and shiny there? And what's that bug doing on it? So you started to ask more and more questions. You started to observe nature as a designer. Once you get the hang of it, I know you've had just a tiny bit of practice, but over the course of this class, hopefully you'll start to realize that all those why questions are leading to, why does the organism exhibit these characteristics? Why is it using these materials? Why does it have these shapes or forms? Why is it going through these processes? Or why is it using these types of chemistries? And why is it using these internal systems? And why is it part of these external systems? So your questions are specific, but underlying all of them, you're starting to ask these basic questions about, why does the organism exhibit these characteristics? As you do that, you don't stop with the first question. You might ask why, and then you find an answer, well, because blank. And then you don't stop there. You relentlessly ask why 3 and 4 and 5 times. Well, why does it do that? Well, because of blah, blah, blah. Well, why does it do that? And you keep asking the question, why? Eventually, what you'll end up with, if you keep asking why, is those basic functions. The organism has this characteristic because it's performing a particular function for that organism in that particular context. So when you're observing nature as a designer, you end up asking, what function is this characteristic performing for the organism? And then when you dive into it even deeper, you realize that almost every characteristic that you see in an organism performs more than one function. So when you discover one function, you'll ask, what other functions might this characteristic be performing for the organism? And that's when you start to get into the real gem of biomimetic design. Okay, so we're all about now figuring out what functions that different characteristics are performing for an organism. And that begs kind of the obvious question, well, why perform any of these functions, or all of them, or in that particular way? Well, that's because all organisms have to undergo metabolism, so they have to convert energy into a usable form. They maintain homeostasis, which means they have a boundary which they have to maintain, and they maintain conditions within that boundary. So they have to maintain a certain kind of internal environment. They have to possess a capacity to grow. They're not always growing, but they have to have that capacity. They have to be able to respond to stimuli. They have to be able to reproduce, and they have to be able to adapt to their environments in successive generations. So this, in fact, by some people's definition, this is the definition of something that's alive. If they're missing any of these things, they're either dead, in other words, they were alive but they no longer are alive, or they're inanimate. Okay, so that's the biggest difference between the biotic part, or the living part of nature, and the abiotic part. And that's why in biomimetic design, we look at nature, but when we're trying to come up with biomimetic design, we look at the living or the biotic part of nature. So we don't look to rocks, we don't look to even the hydrologic cycle, which is water. Okay, so organisms in nature have these characteristics in order to perform functions, and they're trying to perform all the functions they need to stay alive, which is this set of things. they have to do that under these conditions. So all of us, and you're an organism too, so you have to perform all these functions on the conditions that we happen to have here on Earth. And that's that Earth is water-based. That's why we call it, the blue planet. It's mostly covered with water. It's some 2/3 water. Your body is, around 2/3 water. It changes over your lifetime. So we're a water-based planet. So it has to do all these things using water-based chemistry in watery environments, water-based environments. Earth is in a state of dynamic non-equilibrium. That's a whole lot of syllables to say that the Earth is constantly changing. So dynamic means it's always changing, and non-equilibrium means it's not changing in the same way all the time. So the weather we're experiencing today is not exactly the same as the weather we're experiencing exactly 1 year ago today, right? So you can see that. So it's not a uniform sort of dynamism, if I said that properly. And also, as you all know as sustainability people, is that the Earth has certain limits and boundaries. We actually live on this really shallow shell on the surface of the Earth, and a little bit into the atmosphere, a little bit into the water, but we're pretty much limited to this really thin shell around the Earth. We have limited resources, of course, of all sorts, and we've got boundaries that we can all live within. Even sunshine is limited. Only a certain amount of solar energy falls on any given unit of Earth over a given period of time. So we have to perform all the things we do as organisms under these conditions. Okay? Now, the really interesting thing is, as sustainable designers, you can keep in mind that everything you design has to function under these conditions also. And a lot of the designs we call not sustainable ignore one or more of these conditions, and ultimately it's not sustainable, right? And we'll get way more into this stuff once we get into life's principles and later in the course. Okay, so that's why we have these functions, but why do we care about these functions that organisms are performing? I mean, you're sustainable designers, you want to design things and processes and systems. Why do you care about these functions that organisms perform? Well, if you remember this picture from last time, and maybe in your spots that you identified when you did your first BCI session, maybe you observed a piece of grass, right? We were all familiar with lawns. Even in an urban environment, we have blades of grass, right? A whole lot of them, and they just sit there, and we sort of take them, for granted. They almost seem artificial, right? But if you looked at all the functions one blade of grass performs, it performs more functions in a way that humans have yet to be able to figure out how to do. Okay, so it can generate usable forms of energy. It can generate structures, its own structure. It can create sugars that it itself uses, and then it feeds into the soil. It can be eaten, so it's edible. It's an edible solar collecting device that's completely regenerative, renewable. It's restorative. It actually performs many different functions within the greater system in which it lives, in addition to generating solar energy. So if you ask some designer, ask yourself, or someone said, I want you to design an energy collecting device that's also based on renewable energy, and the device itself is renewable, and it can reproduce itself, and it's non-toxic. In fact, it's edible, and at the end of its design life, it feeds the soil and goes right back into the cycle of things. I mean, that seems like a ridiculously impossible task, and yet every single blade of grass and every lawn you see can perform all those functions. And that's not all it performs, of course. And now you look at the wild diversity of things on Earth, and of course here's only a tiny bit of them, and you yourself are one of those organisms, right? If you start looking at all the functions that all these organisms across our biosphere can perform, it's mind-blowing. There's not a single thing that you could think of as a designer that you want to design into, some function you want to design into whatever device or process or system you're trying to do, that isn't performed in nature and performed beautifully and elegantly and completely aligned with nature, and meeting all those operating conditions. That's why we look to functions in nature and why we try and emulate those functions and how they're performed in our designs. Okay, so when you start to continue to practice observing nature as a designer, you're going to get really sharp in your skills of looking for functions in nature, what those functions are, why they're being performed, and how they're being performed. Okay, so that's that. What you're going to do next after this video is you're going to explore the Ask Nature site. Some of you may have been there before, either in other MCAD classes, or those of you who are in MCAD, explore this on your own. If you've gotten into biomimicry at all, you almost have certainly have gone to this site. But what I want you to go back to the site. This is your landing site for Ask Nature, and then you're going to go up here and click on the taxonomy. You'll land on this page. If there's a better way to skip this page, go ahead and do it. And then you click on right here, and you end up on this page, the Biomimicry Taxonomy Biology Organized by Challenge. So I want you to read this page, okay, and then I want you to go ahead and go through these steps here, and then I want you to download the PDF of this taxonomy. Okay, so this is the Biomimicry Institute, or Biomimicry 3.8's Biomimicry Taxonomy, and it's not perfect, but we're going to be using that in this course to understand function. And you're going to download something like this. It doesn't have these arrows on it. I'm just pointing out, when you download it, they have here the green is group and the gray is subgroup and this light gray is function. Okay, that's not, it's a little confusing, so just kind of ignore that. Like, these aren't functional words, okay? So like the words permanently, obviously that's an adverb, that's not a function. So I think what they really mean is for you to enter here, okay? So the function, for example, is to move or stay put, so, which is either attach or move. So let's say you want to move in or on solids. You want to move in or out of liquid. So the function is to move, and then they get into more detail as you radiate out. Okay, so you start to get the idea of the verbs they use in here, like move, stay put, maintain. Or what are you maintaining? You're maintaining physical integrity. So get used to the language that they use to describe functions. And that I want you to get used to that. This is not by no means exhaustive. They've done a really good job of trying to capture everything, all the functions performed in nature, into one table. They've done a really great job of that. And so you can, but don't feel yourself completely limited to these terms, but it's a really great place to start. So you're going to familiarize yourself with those, and then in your next BCI session, you're actually going to have a purpose to it. The first time where you're just being and kind of getting used to the whole process. And I hope that was great. I bet some of you it was really challenging to do a whole 30 minutes, and maybe some of you took longer. But in this next session, you're going to follow the BCI, but this time when you get to the C, or the contemplate part, we're going to look at how functions are performed by organisms that you find at your natural spots. You're going to really get to know your natural spot. Feel free to change around your spot. I mean, it's really nice to go to the same one all the time and get to know it deeper and deeper. But if you feel like you can get better use out of another place, by all means, go do that. And then in the Imagine section of BCI, you're going to imagine how you might apply these strategies in a design. Okay, so I hope you have a really interesting time playing around with functions at your natural spot or your special spot, and I will see you in the next video.